Okay, good afternoon all.
Yes.
Yeah, so for this session, we are fortunate that we are having a young, very dynamic speaker amongst us, Mr. Jay Thakor. So,
Hi.
welcome, yes, sir.
Thank you.
Mr. Jay Thakor is a strong business development professional, graduated from the Bir Narmad South Gujarat University, Surat. Coming from a background of cybersecurity and forensics, Mr. Jay Thakor has developed keen interest in blockchain and currently he is serving as a founder and CEO in Bitwill. Bitwill is a blockchain-based research and innovation company. Mr. Jay has founded another cybersecurity and military defense company, Spinox, in Singapore, and serving since 2017 to cherish this era of technology and to improve and secure the quality of human life. So, yes, sir, once again, welcome for the session.
Thanks a lot.
Yes, sir. Now, sir, you can proceed. Thank you, sir.
For sure. So, hello all. As I was introduced, my name is Jay Thakor, and let us begin the session with all your permission, shall we?
Yes, sir.
Yeah, yes.
Perfect. Perfect. So sorry to interrupt. First of all, before we begin, this is all about unfurling the knowledge that was recently founded, and blockchain is really an epitome of finance and security. I can say I must epitomize this wonderful technology. So please allow me less than 1 minute to start with a prayer to invoke the student among us, and let's begin. Asatoma Sat Gamaya Tamasoma Jyotirgamaya Mrityorma Amritam Gamaya Shanti Shanti Om. So we just invoke the prayer that,
Thank you.
from darkness to light, from death to life. Let the
Yes,
divine
great,
guide
sir.
us all. And let's begin. Let's begin the fun thing. Yeah.
Yes.
So today's topic is blockchain transaction. You know, and first of all, as they told me, as they told every one of you, who am I? I'm a blockchain entrepreneur and researcher. I've done cyber forensics, and now currently I am a crypto citizen, I can say. And what do I mean by crypto citizen? That I don't keep money, I don't need money because I use blockchain asset to, carry my regular life. I can pay the bills from blockchain for, say, Bitcoins. I can use Bitcoins for buying a house, for a car, for gift cards, and even currently I'm in United States and I purchased my tickets from Bitcoin from Abit Sky. So I'll definitely tell you more about this, but that's who I am. And currently, I represent the company called Bitwill. So Bitwill is a blockchain inheritance company, basically. So without taking your private key, we have innovated that we can secure and recover the crypto asset if anyone is, having untimely death or if anyone lost their private key or wallet access. Before that, if they have instated our smart contract from the Bitwill, we can definitely recover that. Apart from that, we have a trust-free crypto management solution as well as a compliance. We audit the businesses, we audit the blockchain, and we give them the compliance. And we can proudly say that we have secured more than 55,247.291 Bitcoins till this date. Okay, so that's us. And let's get to the topic, what we are going to learn today. So the first of all, I will share the basic blockchain architecture. What is that? How the blockchain flows. The second thing would be the main core topic of today, the blockchain transactions, the signing algorithm, systems, and flow. The other thing would be the blockchain wallet and nodes. What are these? How they cherish into the transaction, making the transaction fulfilled with these kind of factors. Apart from that, the transactional verification system, also known as mining or proof of stake. Apart from that, different consensus mechanism on the blockchain. And lastly, what you and me can do to make ourselves secure and not get scammed or hacked. So I'll share basic security countermeasures for blockchain secure transaction. So shall we start with the blockchain architecture? So at the very core of it, it's application layer because you use mobile phone, you use laptop, tablets, the web browser, and with that, these all are the applications. So at the application layer of blockchain architecture, there is a programmable currency, means you can program into Bitcoins, into the smart contracts, into any of this recent innovation on blockchain. Then you can program the finance on top of it, and then you can program the society. So these are three factors. Apart from the on the application layer, there's a programmable currency, programmable finance, and programmable. So because the way the whole paradigm shift happened in the blockchain can
You are not audible, sir. Hello? Hello? तुम्ही mute केलं sir सरांनी.
hello, hello, am I
हाँ
audible?
हाँ sir. हाँ,
Yeah.
now you are audible, sir.
Okay. So whatever I have mentioned earlier, was that clear or no?
Yes, sir. It's a clear.
Okay. So from where I did, from where, which point I was mute.
No,
Uh,
just
uh,
for 2 minutes, not more than that.
Oh, for 2 minutes. Okay. Okay.
Yeah, yeah, yeah. It's
Perfect.
just for 2, 3 minutes, not more than that.
No worries. No worries. No worries.
Yeah.
Let's begin. Yeah. So this is the first blockchain architecture that I'm going to represent. So on the top of everything, there is always an application layer because from your mobile phone, from your laptop, from your web browser, you use the applications to interact with the technology. So first layer is a application layer, and which comes with certain system, which is a programmable currency. So on top of the application layer, there are three things we have to take care of. First thing, you have a concept that this particular currency or Bitcoin or whatever coin it is have a specific utility. So you program that utility into the set of rules of blockchain. And then you can, from the programmable currency, you can inherit the programmable finance because this can change the whole paradigm shift into the world of finance. And once it does that, you can program the society. So that's the application layer. The other thing is a contract layer. So once the key is designed, once the key code, the source code is designed, the second layer of the contract is how much consensus you're going to put, what kind of mechanism you're going to put, what kind of algorithm you're going to, for say I have a kid, and I will give $50 to my kid only to have the breakfast or lunch. I don't want him to spend into the games and all, right? So I will put a scripting language on it that he can only spend with the McDonald's or Domino's or any other chain, Starbucks and all, to make sure that he only spend the money which he meant to spend the money, where he meant to spend the money, and not to buy the funny things out of it. So that's why blockchain have that particular, that enhancement, that particular technology, the facility that you can script and you can code the algorithm and make a smart contract out of it to make sure that the assets are used in a way it should. The third is incentive layer. Now, I must tell you, we all know that there is a centralized system, there is a boring banking system where one man or one institution controls every ledger. But there is an incentive layer in blockchain, which is decentralized. Decentralized means me, you, everyone who holds the token can definitely interact with it, can verify it, and then make the system go running. But if I mine this, if I verify the blockchain, what's in for me? There has to be some incentive, right? Because we don't work for free, do we? So there's an incentive layer for the blockchain. That means whenever a coin is mined or verified with whatever the mechanism is, we will discuss it further. There is always an incentive to verify it. Suppose you are verifying the blockchain, I'm verifying the blockchain, we get some incentive. So there is a third layer, which is programmed as a currency issue mechanism, means upon the successful mining or upon the successful verification, we give certain rewards to the people. And then there is a currency distribution mechanism that every time, the blockchain has a very famous terms called block halving. Block halving means today I'm mining and I'm getting 16 Bitcoin. Tomorrow I may get just 6 or maybe 7 or maybe 3, The blocks get divided into half all the time to make sure that it's a deflative economy. Other thing is a consensus layer. Now, what consensus means is it plays a role of verification that if I'm giving you $5, then it should be it should reflect in my wallet. It should not be double spended or fake currency, right? So to make sure that system is auditable and verificational, we have a consensus layer. So there are different consensus layers. POW means proof of work. POS is proof of stake. There's a lot of consensus mechanism I will definitely share in upcoming slides. Then there is a network layer. So it is a blockchain, but how the blockchain will interact if there is no network, right? So there has to be a network into it. So there is a network layer for P2P, like peer-to-peer network. Then there is a transmission protocol. Whenever the blockchain transaction is signed, there has to broadcast into the network. And then once the transaction is broadcasted, there is a transmission protocol which distributes this particular transaction to the nodes. Then there is a verification mechanism. Again, like I said, there is a miners who gets incentive to verify the system and keep it running. And then there's a last layer, which is data layer. So data layer is what kind of data blockchain will have. That information is shared in the data layer. The data block, chain structure, timestamp, the hash function, the Merkle tree, and the digital signature. So this is the basic, boring blockchain architecture. Let's go to the more funny stuff, So, hey, you all have a banking system, right? You're not like me because I'm a crypto citizen, so I don't have money. I don't keep money. I don't need money. You can book flight from Bitcoins. You can book, a lot of things from Bitcoin. Like I can buy my house from Bitcoins. I can buy car from Bitcoins. I can buy a gift card from Bitcoin. So basically, I have no monetary requirements, So Bitcoin is everything for me. Just like you are not like me, I guess you should have a banking system. And the thing I hate the banking system is, I'll tell you. So there is a centralized server of banking system. Like let's say, for an example, in the illustration here, there are ATMs, there are bank branches, there are mobile banking, the online internet banking, and they all are connected with the intermediate networks, right? These networks further are connected to the centralized database of that bank. And then that database is keeping the ledger of how much money you have in your bank, right? So for say, take an example of Bank of India or Citibank, right? So if you have an account in Bank of India, what happens is basically all of that ledger, when I go to the bank and deposit $5 or 500 rupees, what happens is the teller, the gateway, he opens the gateway, he opens the portal, and then he marked as money received. He will deposit that money into your bank account, okay? And then he will get the fiat money from you, deposit into the bank account. You will get the notification in your mobile phone that money is received. When you transfer that money to me, right? What you will do is you will use the same mobile phone or ATM or any other application, the traditional banking system. You will use their server and transfer it to me. But are you really getting the money, or am I really getting the money? Because these are just the numbers, right? What you see in your mobile phone screen or the internet screen, these are just the numbers. They do not have any tangible value. And furthermore, I do not meant to create the chaos, but human have the system in their control, not the maths, not the mathematics. And the problem with the humans are so wonderful creatures, but they are susceptible to corruption, greed, and all of that, So because of that, people can manipulate it. ING Bank, all of these banks I can name off, they have created a massive millions of dollars worth of scams in the traditional banking system. So basically, that really is hazy thing, that's really sketchy thing. Apart from that, suppose I just landed in United States 2 weeks ago and I paid $2 more for each rupees, as a transactional forex rate. It's crazy. So traditional transactional system is literally getting juice out of people and not serving really well. So for that reason, we have, ta-da, new system. That's a blockchain. So let me tell you how the blockchain transaction work. Okay. So first of all, if you do any transaction, you will require a wallet, because just like a traditional banking system or the fiat currency, from your wallet, you give me 10 rupees, 15 rupees, 20 rupees, right? Just like that, there is a software or hardware which is encapsulated in a way that has some blockchain protocols and set of code which have your private key and public key. So blockchain wallet is nothing, but it just have your private key, public key, and some set of code to sign the transaction and broadcast it. So first of all, there is a Bitcoin wallet or computer or ATM. Then on the step 2, you meant to send some Bitcoins or some cryptocurrencies to someone, right? So you will create a transaction. Now the block that represents the transaction is created. In the third thing, whenever the transaction is signed and broadcasted, the block is sent to every node in the network. Okay, node are just like an accountant. They fetch all the transaction, synchronize with each other, and then send directly to the step for the miners. So now node will validate the transaction, and then they will send it, they will synchronize it with the miners. Now node also receive a reward for proof of work. On the fifth side, on the fifth step, upon the successful verification of each block, incentive protocol will work and the block is added to the existing blockchain and the miners will get reward out of it. And on the sixth step, transaction complete. Hooray, you got the Bitcoins. So that's how the whole blockchain mechanism and transactional flow works. Now, let us unfurl what are the different blockchain components. First of all, it's a blockchain wallet, which keeps, I cannot say it keeps your Bitcoins or the, your crypto asset, but it keeps the ledger and it keeps the authentication mechanism of your assets. Your assets are literally kept in the cloud, in the blockchain, not in the wallet. Okay, mind that. It's not like banking. Second thing is node. Node are that funny whisperers that whenever I get the transaction, I'll tell someone else, I'll tell to someone else, I'll tell everyone else. So these are node. So if I get any transaction, if I'm supposed to be a node, I will tell all my buddy nodes that, hey, I got a transaction, please copy it. And every node will copy this transaction and then we'll send it further to the miners. So second is a node. Third is a network or internet. No transaction can happen without the network's acknowledgement. And now you'll be more than happy to know that it's not, the blockchain has no barriers of internet. Even if tomorrow governments or any other malicious party shut down the internet, then we have a block stream, the satellite for blockchain. We have a radio waves communication technology that with which we can still flourish the blockchain and keep it running. So it's really impeccable, I must say. And fourth thing is, just like I said, miners who verify and keep the system secure and running. So that's a whole system. Now, let's switch to the cryptographic transaction signing system. So in this thing, you already know the transaction flow, that how the system is flowing. Now, at the other side, you will see what are the forensics, what are the depth of it, how the transaction is created, how it is normal terms, what is a blockchain transaction, how it's really bulky and it's not like, traditional signing system. So first of all, there are two guys in transaction, two parties, two institution, or two peers, okay? A sender and receiver. The sender will sign an amount or authentication. Here I took in figure 1.0, I took the privilege to discuss the Bitcoin system because Bitcoin was the first application of blockchain. So let's take that for an example. Whenever the sender gets the amount that I have to send 5 Bitcoins to this guy, so he will put this amount into the wallet. And once the amount is added, he will also add the public key of the receiver. Once the public key is added, with the private key, he will sign the transaction, just like you sign the check, and then the digital signature is created. After that, the hashing algorithm will hash whole system. And then with the public key of receiver, that will be decrypted and then signature will be validated according to that node whispering technique and the mining. And then receiver will acknowledge the confirmation that I got it, So this is how the whole cryptographic transaction signing system happens. It's very simple. Once a transaction is broadcasted, node always verify it. Then, miners always mine it. And then you get the confirmation from the block explorer. And I'll share how the block explorer works. Just a moment, let me switch the tab. So this is another tab, it's a browser. See, blockchain.info is one of the block explorer. You can also make your own block explorer and node. So here, if you go to any transaction, you will be able to see, this is a transaction recently happened. This is the hash function of it. This is the public key, and this is a sender and receiver. Okay. And now here's the amount. See, this much money was transferred, $17,058.34. It already got 5 confirmation, means 5 different peers has already mined this. So this is how a transaction looks like. I hope the screen is visible. Now let's switch to the previous window. Let's go there. again. So this was a transactional signing system. If you have any question regarding this, please note it down. I will definitely uh, reveal all of that, questions and answers and all of that doubt once we finish this presentation. So now let's get to literally more insight into the crypto transactional forensics, how a transaction work, what are the technical parts of it. So first of all, let us understand what is transaction. A transaction represents an interconnection between two parties, two or more parties, basically. With cryptocurrencies, for example, a transaction represents a transfer of cryptocurrency between a blockchain network and the users. For business to business scenarios, a transaction could be way of recording activities occurring on digital or physical assets. This figure one, shows a notional example of cryptocurrency transaction. Each block in blockchain can contain zero or more transaction. For some blockchain implementation, a constant supply of new block, even with zero transaction, is critical to maintain the security of blockchain network by having a constant supply of new block being published, because it prevents the malicious users for ever catching up and manufacturing a longer altered blockchain. So that is a basic security protocol that blockchain has. The data which comprises a transaction can be different for every blockchain implementation because it's hashed. However, the mechanism for transacting is largely the same. Definitely, it's a blockchain, it's the same mechanism. A blockchain network user sends information to the blockchain network. The information sent may include the sender's address, just like I said earlier, or the relevant identifier, sender's public key, a digital signature, transaction inputs and transaction outputs. I'll tell what the inputs and outputs. See, the inputs are usually a list of digital assets to be transferred. A transaction will reference the source of digital asset, either the previous transaction where it was given to the sender, or for the case of new digital asset, the origin event. Like I said, suppose I need to send you 5 Bitcoins, right? To send you guys a 5 Bitcoins, first of all, blockchain has to verify that whether I'm having that 5 Bitcoins or not. So from where the 5 Bitcoin came into my wallet, right? So blockchain has to verify that. In case of the cryptocurrencies, this means that value cannot be added or removed from existent digital asset. Instead, a single digital asset can be split into multiple new digital assets, each with a lesser value, because every time I transfer, I have to pay some blockchain fee, transfer fee. Or multiple digital asset can be combined from few or new digital asset with the corresponding rate value. Interchain mechanism also can happen. The splitting or joining of asset will be specified within the transactional output. So now we switch to the outputs. What are the outputs? The outputs are usually the accounts that will be the recipients of the digital address, along with how much digital asset they will receive. Each output specifies the number of digital asset to be transferred to the new owners, identifiers of new owners, and set of conditions new owners must meet to spend that value. If the digital asset provided are more than required, the extra fund may be explicitly sent back to the sender. So it's a mechanism to make change. Just like in a banking system, what happens that you have 10 rupees in your account, you have to send me 5 rupees, so will just send me 5 rupees and 5 rupees will remain with you. In blockchain, what happens is, if I have 10 rupees, if 10 Bitcoins in my wallet and I need to send you 5 Bitcoins, then new transactions input and output will be created. So in that combined data, my data will be 5 Bitcoins sent to XYZ, Bharati Vidyapit. And then, so what blockchain will do is it will not just detect 5 Bitcoins. So the new block will create it, the transaction will be created, which will have 10 Bitcoins in the transaction, 5 of which will be sent to Bharati Vidyapit and 5 of which will be reimbursed to me on the source wallet to make sure that I have enough input and output by my side. You see? So this is how the whole blockchain mechanism works. And now let's take an example that Alice has $20 from the previous transaction and the transaction ID 0x14. The input is $20, output is $17, right? Because Alice have to spend $17 to Bob. So the remaining output one is $3. So Alice sent $17 to Bob in the transaction ID 0x15, and then on the output Bob sent $17 to someone else. It's Bob's business to do it. So this how the whole chain of custody is happening. Now, once the output one of Alice, right, generated, Alice also sent herself 3s change. So it's not like if she has a $20, she will just send $17 to Bob. It is like she's spending $20, sending 17 to Bob and $3 to herself. This is how the whole blockchain mechanism works. So now a transaction represents an interaction between parties. With the cryptocurrencies, a transaction represents the transfer of cryptocurrency between blockchain network and the users. For business to business scenarios, a transaction could be a way of recording activities occurring on a digital or physical asset, right? So basically, what I'm trying to share, or what this particular presentation is trying to share, is you have your own. See, whenever I'm doing the transaction, right, I have to identify you, you have to identify me. So to identify each other, there is a key set. There is a public key and there is a private key, right? Your public key is your, I can say, your similar to your bank account, equivalent to your bank account, and your private key is your password, okay, with which you can sign the transaction and broadcast it in the ledger of blockchain. So what kind of public key and private key pair infrastructure is used in the blockchain system currently? To be very specific, in the Bitcoin system is a ECDSA, elliptic curve digital signature algorithm. It is used as digital signing mechanism to generate the private key and public key. So just like I said every time, even in my company, that let us not trust, let us verify, because blockchain is a trust-free protocol. So how can I verify this is you and this is me, right? We can share each other's public key identifier, and then that will verify that rather this transaction is went to your public key, to you or someone else. I cannot lie in the blockchain. So what is ECDSA? Let's learn about the ECDSA. It is an elliptic curve digital signature algorithm. It is a cryptographic algorithm used by a blockchain to ensure that funds can only be spent by the rightful owner and no one else, right? It consists of very two things: private key and public key. Private key is a secret number known only to the person that generate it. Okay. A private key is essentially a randomly generated number. In Bitcoin, someone with a private key that corresponds to the fund on that particular blockchain can spend the funds. It does not have any KYC, no, nothing is needed for you. Just your private key and public key will have the access of the funds. In Bitcoin, a private key is a single unsigned 256-bit integer, 32 bytes integer, okay, which consists ones and zeros, capital and small, string. And the public key is a number which is derived from a private key, which is calculated from a private key. And it's okay if you don't keep it secret. It's okay if you publish it in Times of India. It's just a public key. Just like you can make curd out of milk and buttermilk out of milk, but you can't make milk out of the curd. Just like that, you can make public key from the private key, but you can't make a private key from a public key. You can't derive the private key from the public key. So it does not need to be kept secret. You can share it with anyone. So a public key can be used to determine if a signature is genuine or not. In other words, it's produced with the proper key or not. Without requiring the private key, without sharing my secret. In Bitcoin, public keys are either compressed or uncompressed. Compressed public keys are 33 bytes, consisting of a prefix either 0x02 or 0x03, and 256-bit integer are called X. The older uncompressed key are 65 bytes, consisting of constant prefix like 0x04. You have that Ethereum address and all. It's like that. Followed by two integers, 256-bit integers called X and Y. So it's a 2 into 32 bytes. And the prefix of a compressed key allows Y value to be derived from the X value. You see, so there is a public key identifier, and from that you can generate as many as public address that you want, the X and Y. Now, all of the key pair is generated, but where will you keep it? Where will you administer the whole chain signing mechanism? So that comes the blockchain wallet. Now, be assured and be aware, blockchain wallet is just a pseudonym, but wallet is actually a software program that enables user to buy, sell, and transact or monitor the balance of their digital assets or authenticate the digital asset. if you are involved in exchange of Bitcoin, Ethereum, any other cryptocurrencies, then it has to have usage of a blockchain wallet of any type. There are different types of blockchain wallet. But what I was trying to say is, wallet does not mean that traditional wallet where you keep your Bitcoins. Bitcoins are not kept in the wallet. Wallet is just a set of code which will enable you to sign the transaction from your public key and private key. Okay, which will enable you to download the ledger. It will not have the Bitcoin as in wallet. What will just synchronize with the blockchain. So where is my Bitcoin if it's not in the wallet? It's up there in the sky. It's in the network. It's within the blockchain. Okay, so keep that in mind. It's not like traditional banking system where a centralized server can keep your funds. No, every node will keep your funds to make sure that no one lies, no one steal your funds. It's ultra secure. So wallet is just synchronizational software protocol. Okay. Unlike traditional pocket wallet, just like I said, wallet do not save blockchain cryptocurrencies. They keep a record of transaction, related to the cryptocurrencies and store them on blockchain. Every blockchain wallet contains wallet unique key pair generation mechanism, public key and private key, which is used to authenticate outgoing transaction and generate receiving address to accept the cryptocurrency in respective wallet. All these transactions which are kept on blockchain requires a valid key signature to digitally sign the transaction and authenticate it to be broadcasted with updated ledger to the blockchain. A wallet message, all these essential functions like generating a key pair, generating the transaction, signing the transaction, public key and private key broadcasting to the updated ledger to the blockchain, and again synchronize the new amount, new balance and all. And it also have the blockchain, it also can redirect to the blockchain, I can say Explorer to this. So that's what the wallet does. Now there are two types of wallet. See, wallet is just a wallet, but there are two different types of where you keep your key. So that's how we used to refer as two types of wallet: hot wallet and cold wallet, also known as online wallet and offline wallet. See, wallet does not need internet. It only needs internet or the network when it updates the ledger within the wallet. It downloads a copy of ledger, and when it broadcasts it. To sign a transaction, you don't need an internet, first of all. So there are two types of wallet, online and offline. Online wallet has key stored online on that server. Offline wallet has offline key storage. So in online wallet, the pros and cons are highly accessible. The funds are highly accessible from anywhere you can access it. It's connected to the internet, but it is really vulnerable to phishing and hacking. A lot of wallet got hacked. At the other side, cold wallet, offline wallet, is a highly secure wallet. It is not connected to internet at all. And the issue is it's less accessible. You have to keep that offline wallet everywhere you go. It's not very commutable. It's cumbersome, but it's ultra secure. Now there are wallet platforms. There's a hardware wallet, which stores a private key of users on hardware devices like USB, like a mobile phone, a lot of things, like titanium plate. Then there is another wallet called paper wallet. So paper wallet just have private key and public key. So it will just consist of your two things: private key, public key, and their barcodes. Nothing more, nothing less. So with paper wallet, you definitely can generate a private key, public key, and print it out on a paper. But whenever you need to initiate the transfer, you need a software or hardware wallet. You need a platform. You need a set of code to sign the transaction and broadcast it. You can't just broadcast it with just set of paper, you see. So you need some kind of adaptation for that. But to receive it, you can just carry a paper of a public key and then receive it anywhere. You don't need a private key to receive it. And then the last thing is a software wallet. So in the software wallet, it's just a set of application which has different utilities, different features, and three kind of software wallet. Desktop wallet, you can download it in your PC or laptop, and then you can operate your crypto funds from there. But the limitation of that is, trust me, it's killing me to say that, but majority of all the computers are susceptible for hacking, like man in the middle, evil twin attack, interception. So there are a lot of attacks. It's currently going on with this, even in the pandemic. So it's less secure. You may lose your funds in two ways. Once, if it got hacked. Second, if you have any hardware or software failure. So desktop wallet is not really secure, but if you have a backup, you can use that. Other thing is an online wallet. Like I said, you host the wallet in the cloud. You can use blockchain.info wallet or any other wallet. It's an online service. But again, the private key is stored with them. So if the company, like some scam company, if they go away, then you lose your funds. The other wallet is a mobile phone wallet, which is very handy, which has QR codes. You can scan the QR code, transaction, you can sign and broadcast it anywhere. Mobile wallet, I can say that these mobiles, the new age mobiles, are more secure than the computers and other devices, I can say. So you can have the mobile phone wallet, and you can use the paper wallet and mobile phone wallet combined and hardware wallet to make sure that you can do transactions swiftly and easily. And one thing I would like to say that no system is 100% secure, but Samsung has a secured folder as well as the secure elements, the dedicated chip to it. So it's better and secure than Apple, compared to Apple. I mean, they're not paying me for the promotion, but that's what I use for a mobile phone wallet. It's very secure. Now let's switch to the blockchain nodes. So have you ever imagined that what happens once you sign the transaction? Where does the transaction goes? Just like I said, it goes to the internet. But after the internet, who synchronized that? Who is the accountant of the blockchain? These are nodes. Nodes are basically the accountants, the ledger keepers. They'll keep your ledger, they will update it, synchronize it amongst the other nodes, and then they will go through the mining mechanism. They'll mine and verify and then add it to the blockchain. Now when the miner attempts to add a new block of transaction to the blockchain, it broadcasts the block to all the nodes on the network based on the block's legitimacy, validity of signature and transaction. Nodes can accept or reject the block. When a node accepts a new block of transaction, it saves and stores on top of the rest of the blocks it's already have stored. In short, nodes check if a block of transaction is valid and accept it or either reject it. Nodes save and store block of transaction, and it also store the whole transaction history of the sending and receiving ledger. Nodes broadcast and spread this transaction history to other nodes. They whisper, to the other node buddies, and they synchronize with the blockchain. And they always update whenever this new transaction, new block happens. Now, there are two kind of nodes: a common nodes and a master node. You know, so a blockchain exists out of block of data, right? This block of data are stored on nodes. Compare it to small set of servers. Nodes can be any kind of devices, mostly computer, laptops, or even bigger server. Nodes from the infrastructure of blockchain, all the nodes are connected with each other. There's a network of nodes. Every node is connected to other node. And they constantly exchange the latest blockchain data with each other. So all the nodes stay up to date. They store, they spread, and preserve the blockchain data. So theoretically, a blockchain exists on node. We shared that where your funds goes, your fund goes to the nodes. Your nodes having your bitcoins, not your wallet. So a full node basically is a device, just like computer or server, that contains a full copy, the entirety of a blockchain transaction history on the blockchain. Now, what are these master nodes? Because in figure 1.4, you can see 1, 2, 3, 4, 5, 6, and all of these is a mesh. It's a network of nodes, right? But in figure B, I would like to share that number 7 and 3 are master nodes. So what this master node will do is some blockchain nodes are also master node. The master node are usually a heavier equipment than normal nodes. It has a better performance, better network, and better storage. Next to validating, saving, and broadcasting transaction, master node also sometimes facilitate other events on the blockchain dependent on their nature, such as governing voting events, providing the execution protocol of operation, and enforcing law according to the blockchain. The master node are generally always online 24/7. It's not like node that you become offline and online according to your facility. Master nodes are 24/7 online. It's hosted with the different protocol like IPFS, interplanetary file system, and so on. It's a really big science of it. I'll definitely share it further. And facilitate more memory than normal nodes. They're superhumans of nodes. They're super nodes. So you can say a master node is like a hosting with a very large server or network, because a hosting master node usually requires very much resources like electricity, uptime, maintenance, storage space, memories, and hosting one generally provides payment in the form of interest. So in this thing, in this figure 1.5, 1, 6, 5, 4, and 2 are the nodes. These are lightweight nodes, like anyone can be the node. But number 7 and 3 are the master nodes. These are heavier, require additional power, and it really requires a wonderful amount of infrastructure. And here is a link of do it yourself. You can also be the node. Just press it in here, then you will redirect it to the link where it will show you how you can too become a node, or you can become a master node. You can start from here. Yes.
Sir, the slide is stuck in cryptography transaction mining system, sir.
Sorry.
Hello. Huh, sir. Slides are stuck.
Stuck in
Hello.
Is it
Huh,
is
sir.
it fine?
It's not moving, sir. Hello.
Just a minute. Just
Just
a
navigate
minute.
next slide,
So
sir.
sorry for the trouble. Screen one. I have shared the screen one. Are you able to see it?
yes, sir.
Is it okay?
Uh, Bitcoin
Yes, sir.
only.com.
Perfect.
This screen share meeting.
Perfect. Yeah. So now I have pressed on this link, bitcoinonly.com. This is one of the website where you can generate your own node. You can be the node too. So let's switch back to the website. We will not make node today for sure. We will learn about it. So apart from the node, what are the miners? Because node is certain, it's like a transactional keeper. It's a bookkeeper basically. It's accountant. But who are the miners? The miners are the very validative guys. They are the validation. They provide validation and verification. So mining is a process of adding transaction records to blockchain's public ledger of past transaction. And a mining rig is colloquial metaphor for a single computer system that performs the necessary computers for mining. So it's not like, please do not imagine that a man with a heavy equipment is mining the Bitcoin. It's not like that. It is just like you have a computer or a mobile phone or a server. You turn on that server. You you put the verificational pre-decide mechanism into this, and based on the consensus, it will automatically verify. Your computer will automatically verify. So you can be the miner too. You can use the miner gate, or I think there is another application. I can say nice hash within your computer to mine this set of bitcoins and all. So you can be the miner. So mining is a process where a computer or set of dedicated computer hardware will verify the transaction, will do a heavy calculation on it, and then once again, as the previous representative shared with you, it will be confirmed. So Bitcoin node use the blockchain to distinguish the legitimate Bitcoin transaction from attempt to respend coin that already is spent elsewhere. So, do you remember that I shared here that in the wallet, there are two types of wallet, the hot wallet and cold wallet, and you do not need a wallet to mine. You don't need a wallet to sign the transaction. You need wallet to broadcast it. So what I will do if I'm a bad actor, I will, if madam needs 5 bitcoins from me, what I will do is I will sign a transaction of 5 bitcoins. I will not broadcast it. I'll just sign it offline. And then if sir tell me, hey Jay, please transfer me 5 Bitcoin too, I will sign the same transaction from the same input and output, just the address is different. And then I will broadcast both of the transaction. So now there is just 5 Bitcoins with me, but I have made transaction of 10 Bitcoins, like 5 Bitcoins to madam, 5 Bitcoin to sir. So I have double spended this, you see. So such activity can happen and does happen in the blockchain. To make sure this activity, it can happen. You can double spend, but nodes will check it and will definitely, invalidate it. It will remove whenever the node will see the suspicious suspicious transaction activity where the same Bitcoin is used twice, with the different address. That is known as double spending, and that double spending will be, so whichever chain, chain A and chain B, this is two chain of the same Bitcoin, the same double spending, whichever chain is verified and the longest chain, that that has a higher amount of confirmation, that will remain in the node, that will be verified, and the other chain will be definitely automatically will be removed from the blockchain. So That's how the mining mechanism has distinguished between the con man and a saint, a genuine user and a con man. So that's what the mining does. So in a nutshell, miners are a really high powered set of computers, a set of CPUs and GPUs used to verify the Bitcoin transaction or any other blockchain transaction by solving the mathematical puzzle, which is generated during the transaction signing phase. Definitely, I will share what are the nonces. Once the blockchain miner solves the puzzle and find the nonces of their particular block, a miner is rewarded with predetermined amount of cryptocurrency. Like I said in the blockchain architecture, the initiative, the main incentive phase. So here is the incentive to mine. If I mine the block, I will get the reward. So currently, the bounty to mine a Bitcoin block after halving is 6.25 Bitcoins. The value of reward half every 210,000 block to maintain the demand and supply with its deflation mechanism. Unlike the money, we don't like money. So these are the different miners. If we talk about the ASIC mining system, proof of work, the miners comes into the picture where there are different hash rate. Different hash rate means the different computing power, and you can buy this miners, plug it into your home or the office, give it internet by Ethernet port, RJ2, RJ45, or wireless port, and then this will mine it for you. Now let's talk about the different consensus mechanism on the blockchain. But I know that I have to share what nonces means. So let's go back. So whenever there is a blockchain wallet, right? Whenever it creates a transaction, generally how it happens is, see here, a sender will send this Bitcoin amount, it will encrypt it, and the digital signature will be created. But whenever the digital signature is created, the system will add a certain amount of entropy, which is also used as nonce. So when the nonces are added from this blockchain, you know after synchronization to the node and goes to the miner, this nonces has to be found. So once the miner will brute force, calculative mechanism, the nonces will be found and will be broadcasted on the blockchain that, see, these are the nonces, and upon the founding of nonces, the miner will get the rewards. So nonces are basically a random set of you know derived calculation to make sure that it's improved every block, and the calculation is complex every time, that the block does not become predictable, you see. So these are the miners. Now let's talk about the consensus mechanism. What are these consensus? Consensus is a group-based protocol for reaching agreement dynamically in a group. See, if I say this is night or this is day, how will you verify it? There has to be a consensus mechanism, because this is a decentralized currency, decentralized mechanism. The whole entirety of blockchain is a decentralized, and it's not all about the Bitcoins. It's more of a financial use case. Yes, there is a financial use case, but apart from that, there is a verification use case. KYC can be verified, intellectual property, authentication. So all these set of rules can be combined in the blockchain, not just the finance. It has really vast set of utility. So compared to every majority voting system, a consensus emphasized that the entire group as a whole could benefit by reaching a consensus. The problem of dynamically getting a consensus in a group relies on group-based coordination. Such coordinated consensus may be tempered in the presence of malicious actors, the evil guys, and faulty process. For example, a bad actor may secretly create a conflicting message to make a group member fail to act in unison, which break down the effectiveness of the group to coordinate its action. So for say we are 10 miners, so two miners will vote yes for the transaction, two miners will vote no. So rest of the miners, what they will do, they will also calculate it, and then they will derive to the yes conclusion that yes, that other two miners are right. So those malicious miners who have voted otherwise will be, you know, decimated, or maybe they will be obliterated. They will not have enough set of proof consensus to make sure that they are right and others are wrong. So here unanimous approach will work, and those two malicious actors will be definitely eliminated from this mining mechanism. So basically, this kind of problem is called Byzantine general problem, BGT. The failure of reaching consensus due to the faulty actors referred to as Byzantine fault. Leslie Lamport, Marshall Pace, and Robert Shostak showed in 1982 that Byzantine fault tolerance can be achieved only if a majority of people agree to reach by the honest general on the strategy. The consensus algorithm, properly used in the current blockchain system, provides a probabilistic solution to BGP. In subsequent sections, we will review this consensus protocol with a focus on the security and privacy properties. So basically, what this paragraph was trying to illustrate is just like I said, when there are actors, when there are 10 actors and two of them are bad actors, we can definitely say that, hey, majority wins, you two bad actors, please go out of the house. But when there are five bad actors or six bad actors, then what happens then? So if we have this BGP issue where the majority of the bad actors, how to verify the whole entirety of the things, that's when the different consensus algorithm happens, So one of which is a proof of work consensus mechanism. The consensus protocol designed by Satoshi Nakamoto the Great for the Bitcoin is aimed at reaching the coordinated consensus from the network on the validity of each Bitcoin transaction. It bypasses the BGP problem by using a proof of work protocol. Means every miner has to work for the vote. It cannot just give the vote for and against the blockchain. We characterize the POW with dual properties. It should be difficult and time consuming for any prover to produce the proof that meets a certain requirement. And two, it should be easy and fast for others to verify the proof and terms of its correctness. For the first property, one must design a proof of work challenge, such as computing a valid proof of work is difficult with low, somewhat random probability like nonces. Thus, a lot of trial and error is needed, like brute forcing. Suppose I can say, hey, I guessed the number from 0 and 9. So you have to do the proof of work. Suppose my guess number is 6, So you have to derive and you have to keep on asking me, hey, Jay, did you assume the word 6? Did you assume the word 1, 2, 3, 4? I'll say no to 1, no to 2, no to 3. And then once you come to 6, I'll say, yeah, I guessed the word 6, the number 6. And once you are right, once you do the proof of work, you will get the rewards. So you have to do certain work to it, to make sure that you derive the correct calculation. So that's how the trial and error is needed. We illustrate how POW works in terms of BGP, and when the troops on the east city want to send a message to the west side of troops, they're situated somewhere, east west. It follows the step of POW protocol proof of work. So for say one, append a nonce. Usually it starts with 0 or anything to the original message. You just need to append a nonces, which is a random hexadecimal value. It's not derived or it's not a deterministic. It's this really random hexadecimal value. Apply that hash to the nonce augmented message and check the hashing result is less than or equal to the present value. So for say if you have zeros, say it starts with the 5 zeros, In the 3, if the hash condition is satisfied, the troops on the other side will send the messenger to the troops on the other side, and the nonce can be determined from that. They will calculate it. If not, then increase the nonce by 1, and the process iterate until desired result is obtained. And finding the right nonces can be time consuming and definitely computationally expensive. Just like I said, I guess a number like 6, then you have to tell me which number is this. So until the 6 is reached, you have to do the work. But I will not tell you the number is 6. I will tell you that the hash of 6 is 00101. So to derive that 00101, you have to work on it. And once you derive that particular thing, you will decrypt the message and you will get the whole entirety of it. So that's how the whole consensus mechanism of proof of work happens. Now, if the hash condition is satisfied, if both of the hash are right, then the troop on the other side of the city will send a messenger that, okay, acknowledged, this is definitely, uh, the correct message. They will say that, hey, hi Jay, and then it will be encrypted and put on that encryption 00101. And then I will iterate it. By here, when it iterates and when it finds an answers, the message decrypts in hi Jay. So I basically get the coordination. So due to the collision resistance property of hash function, it is hard to temper the hash of the message even if the messenger get caught, because of hash's tempered message will be drastically different from the hash of original message. So for say I say let me assume the number 6, right? Let me guess the number 6. The hash of it is 00101, and you already have the hash 00101. Now between me and you there is a third party. Sir is very notorious, and sir actually changes the number to 00111, or maybe he changes number from 6 to 9. So the hash of it will be totally different, you see. So when it gets to you, you will confirm the hash is simply different. There is something tempered in between. So whenever the tampering happens, whenever the man in the middle attack happens, you will get to know it because there is auditable mechanism. And then you have to repeat the above process for multiple iteration. Just like I said, number 1, 2, 3, 4, 5, until you get to 6, the hash of 6. So this how you have to have a proof of work, and this how you can demystify the whole transaction with the proof of work and mine it. Now, proof of work requires the people who own the computers in the network to solve a complex mechanical problem to be able to add block to the chain. Solving the problem is known as mining. Miners are usually rewarded with their work in cryptocurrency, redundant things, blah, 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 blah. But mining isn't easy. It is a mathematical problem, can only be solved with the trial and error, keep on keep on brute forcing, guessing and guessing and guessing. And then once you are solved this equation, about 1 in 5.9 trillion guess, it requires substantial computing power and definitely a lot of energy, a lot of electricity and internet. This means the reward of undertaking the mining must outweigh the cost of computers and the electricity cost of running them, as one computer alone would take years to find the solution. You have a pool of miners, each other sharing the power, and based on the power amount of power they share, they distribute the reward. Let me tell you one thing. Let us interrupt this and let me share very important thing that I cannot resist to share, because whenever they ask me, you use Bitcoin and you referred yourself as a crypto citizen. Why there is a value to blockchain? Why there is a value to blockchain asset and Bitcoin? What is the value? It's just a number, No, it's not like that. I have spent enough amount of energy, time, internet, data, hardware, and electricity to mine one Bitcoin. So there are base value to it. Base value is time, the value of energy, value of electricity, value of the hardware. So that is a base value that is burnt, spent to generate one Bitcoin. So definitely Bitcoin have a base value. The cryptocurrency asset do have a base value. I will not talk about the alternative coins because every alternative coin based on the Bitcoin, they definitely have a base value of Bitcoin. So if Bitcoin goes to zero, no other cryptocurrency can survive. Very blunt and bold statement, but that's true. Okay, so these are the base value, you know, that flourishes the system. And currently Bitcoin is more than $19,000. When I involved myself into the Bitcoin, it was around 132 or $135 when it was first introduced to me when I was learning the cyber forensics. However, from that to today, the mining became harder and harder and harder. And then, hence, I have to spend more and more to mine one Bitcoin. Hence, there is a value of $19,000 in the Bitcoin. So it's a really valuable asset. Now, we know about the proof of work, but then the power of mining, according to the Cambridge Bitcoin electricity consumption index, it estimates that the Bitcoin mining network consumes 70 terawatt hours of electricity per year, ranking it in 40th largest consumer of electricity by country in Cambridge. And by the way, of comparison, in Ireland, ranked 68th, uses over third Bitcoin's consumption, or 25 terawatt hour, and Australia at the other side, 42nd, consumes 64.6 terawatt hour of electricity per year, according to the 2016 data compiled by the CIA. Why I'm sharing this boring stuff? To make you understand that we are consuming a lot of electricity to mine the bitcoins. So Bitcoin is not just a thin thing in the air. It's really wonderful, amazing economy of verification, authentication, and proof of funds. So the problem with the proof of work is really simple. Basically, proof of work really requires prominent work, and all the miners are competing with each other in proof of works. So there is a redundant amount of efforts and energies burnt, but to derive the singular result. So a lot of energy is being wasted, and it's really not at the good, economic if you do the proof of work, but it's really very secured at the other side. So to create economic of scale, miner often pool their resources. Just like I said, I have a miner, you have a miner. Let's create a pool and mine it together. Through the companies that aggregate a large group of miners, these miners then share the rewards and fees offered by the blockchain network. As the blockchain grows, more computers join and try to solve the problem. The problem obviously get harder as the network gets larger. Theoretically, distributing the chain further and making it even more difficult to sabotage or hack to make it immutable. In practice, though, mining power has become concentrated in the heads of a few mining pools like, Slush, BitPay, then Bitmain. There are a lot of pools who actually control the, mining power. So that's why that's big con of it. These larger organizations have a vast computing and electrical power now needed to maintain and grow the blockchain network based around the proof of work validation. Enough of the proof of work, enough work we have done on the proof of work. Let's switch to proof of stake. Now, the proof of work and proof of stake has some difference of mechanism, and pardon me, let me share this thing. See, proof of work is literally, as they say, it's a decentralized, but I used to refer the proof of work as a centralized, and I'll tell you why proof of work is centralized. Because just like I said, some of the miners, some of the pool, they literally control the majority of the hash power. So that's how it became centralized. It meant to be the decentralized, but it became centralized because the people with power can definitely control it. The hardware tools, ASICs and CPUs and energy is really highly consumed. So if I cannot afford these kind of costs, then the big guys can definitely control it. At the other side, what are the different consensus as apart from proof of work is a proof of stake? Means it is highly decentralized. There are no hardware tools or energy, really a big amount of energy required to have a proof of stake consensus. Just like in proof of work, we have different miners. In proof of stake, we have a different stakeholders. So in the proof of stake, later blockchain network has adopted proof of stake mechanism. Validation consensus protocol where all the participants, sorry for stuttering, participants must have stake in the blockchain. They are the stakeholders, usually by owning some of the cryptocurrencies on their wallet to be in with the chance of selecting, verifying, and validating the transaction. This saves substantial computing power, resources, because no mining is needed. In addition, blockchain technologies have evolved into the smart contracts, which automatically execute the transaction when certain conditions have met. So the proof of stake, POS, represents an alternative type of distributive consensus protocol for ensuring the cap properties of public blockchain, and it breaks the dependency on the reward of securing by promoting the penalty-based solution. For say, if you are a miner, right? And if you mine the blockchain. Now, if you are a bad miner and if you tweak with the protocol, right, there are no penalties. We may get rid of you from the blockchain, but there are no penalties. Whereas in proof of stake, the improved mechanism, there are penalties. So for say we are 5 people, right, in the room. So 5 of us will have $10 each. And now, whenever the new block comes in, we all will vote. I mean, automatically, the voting system will happen. But if we vote as a transaction is valid, and if in reality the transaction is not valid, right? And some of us literally catches that, hey, the transaction is not valid, then the bad actors who miscalculated and misvoted this and misused their privileges will be definitely penalized. So they have to lose their stake, which they put it on, the verification. And then once they lose that stake, I mean, definitely you are penalized for this. So next time you will be careful. So this is how the proof of stake is comparatively, secured and distributive, have less amount of energy. They use really less amount of energy to make sure that everyone can participate in proof of stake, and it is highly economical at the other side. So the blockchain keeps track of the set validators that have put aside of deposit. Anyone can become a validator, just like anyone can become a miner. But unlike proof of work, you can become validator by sending a special type of transaction to lock up a certain amount, you see, of your own coin into the validator deposit. All the validator have known identifiers, which are stable addresses. In Ethereum, it is a ERC20 smart contract and all. If you want to become a validator in the network keep all the track of legitimate validators like that Ether chain, and those who have reserved coin for participation in validation. Every validators can participate in proposing to create and validate new blocks through the consensus algorithm, the proof of stake consensus algorithm, and which require the set of validators to put the bet on the next block and take turns to vote and decide which validators for the next block is made based on the weight of voting computed by the science of each validator stake. The probability of being selected is proportional to their bet. So these are the comparison of proof of work and proof of stake. Here, each miners solves a computing puzzle to compute, and it requires a processing power to validate. Here, there is no computation, but the block creator is chosen by the algorithm based on user's stake. In order to add a malicious block, you have to have a computer more than 51% of the network power, in the proof of work. In the proof of stake, you have to have a 51%, you have to own the 51% nodes, I mean, stakeholder in cryptocurrency on the network. So for say we are 10 people who is stakeholders, right? So 5 or 6 of them has to be my whisperer or my devotees. So if I say night, they will vote as night. If I say day, they will vote as day. So if I control majority of stakeholder, I can definitely do a malicious activities on that. Here, the miner have to solve the puzzle and then the reward is given. Here, there are no rewards for making a block. So the block creator takes a transaction fee. Basically, there are no mining involved in this. It is just a validation. So once the block is validated, the transaction fee is given to the validator. And if the validator do not validate it well, the stake as a collateral will be gone. So here are the rewards versus penalize proof of stake. Because if you penalize something, you have a better understanding. It is not like proof of work where you can do the proof of work, change your nodes, change all of that things, and then do the funny things with the blockchain. You will be penalized in this kind of mechanism of proof of stake because you have stake to lose. Other mechanism is proof of authority or proof of identity consensus mechanism. The POA, the proof of authority, also referred as proof of identity consensus model, relies on the partial trust of publishing nodes through their known link to the real world identities. Publishing nodes must have their identities proven and verifiable within the network of blockchain. Identifying customers, identifying documents with which have been verified and notarized and include on this blockchain. This particular idea that publishing node is taking identity or the reputation to publish new blocks. the blockchain network user directly affect a publishing node's reputation based on the publishing node's behavior. So publishing nodes can lose reputation by acting in a way that the blockchain network users disagree with, just as they can gain reputation by acting in a manner that the blockchain network user agrees with. So the lower the reputation, the less likelihood of being able to publish the block. Therefore, it is in the best interest of the publishing node to maintain the highest reputation. This algorithm only applies to the permission blockchain networks with a high level of trust. Now, well, proof of authority or identity means that we are, for say, 50 people, you know, and amongst us, we all know each other. There is a proof of identity. We all are identified with certain consensus, certain mechanism, with the KYC or whatever it is, with the public and private key. And then amongst us, the highly valuable of us will vote for this particular blockchain. And if the blockchain and if the nodes, if the transaction is validated upon my publishing or upon my recommendation, this particular transaction will give you the reward of, not just it will give you the reward and incentive, but it will also give you the reputation score. So if you have a good reputation score, that means you are a good actor. And if you have a less reputation score, then you are less likely to, first, A, you are less likely to being able to publish the block. B, if your reputation is jeopardized and if you are doing the funny things with this POA consensus, then you have less level of trust and nobody will trust you. So people may kick you out from the consensus mechanism. So this is proof of authority. The other thing is a round robin consensus model. It is a consensus model that is used in some permission blockchain network. Within the model of consensus, the node takes turns into creating blocks. The round robin consensus has a long history grounded into the distributed system architecture to handle the situations where publishing node is not available to publish a block on its turn. These systems may include a time limit to enable the available nodes to publish the block, so unavailable nodes will not cause a halt into the block publication. The model ensures no one nodes creates the majority of the block. It benefits from a straightforward approach. It lacks cryptographic puzzles and has low power requirement. Since there is a need of trust amongst the nodes, the round robin does not work well in the permissionless blockchain network used by the most cryptocurrencies. This is because malicious nodes could continuously add the additional nodes to increase their odds of publishing new blocks. In the worst case, they could use it to subvert the correct operation of the blockchain network. So for say we have a really wonderful ongoing blockchain network, and when you add the round robin consensus, if I have a bad actors at nodes, they can definitely jeopardize the whole thing, and that they can definitely, you know, uh, mingle with the system, and then they can do the funny things into it, and they can alter the whole entirety of the blockchain ledger. So it's really not, see, even there are many consensus. There are not just four consensus, but the four are widely used. Amongst them, proof of stake and proof of work is really widely used in the blockchain mechanism, in the EOS, in the waves, in Ethereum, in blockchain, in Bitcoin, in Blockstream, in Litecoin, in, I guess, Monero. All of these guys are using proof of stake, either proof of work mechanism. And the other mechanism is a sharding, actually, when they shard the whole Merkle tree, and then everyone keeps a copy of a pre-mined token and all. But actually, it's a really doubtful concept where all the sharders or all the block keepers, if majority of them or some of them are bad actors, then it's not going to get verified. So if I meant to vote, well, we at Bitwill are innovating another consensus, which is a hybrid consensus of proof of stake and proof of work. So our consensus of Bitwill, what it does in reward versus penalty is, for say, you have a mobile phone or you have a computer, right? So currently we are researching that our mechanism, when a block is generated, the node will definitely have a stakeholders. First, users are the stakeholders. They are the validators. So they'll put some stake and validate it. So at the first glance, the blockchain is validated. Now, upon the validation, the proof of work mechanism will interfere and it will try to validate the validator, that whether the validator is genuine or not. And once the validator is genuine, it will give that particular validator a reputation based score, that this validator, every time this validator is maintaining the reputation, and his stake will be uncovered, and it will also given the uh, transactional reward to make sure that he have an incentive. So this hybrid mechanism using proof of work and proof of stake, we are trying to expedite the current blockchain. So for say a block is created and already people are voting for that, if 99% validators are voting for that, then we'll let the transaction go and verify to make sure that there are no further delays, and that 99% are further verified on proof of work mechanism to make sure that integrity of blockchain remains. So that's what we are doing at Bitwill. Soon it will be published and patented. Now, these are some security measure for the transaction on daily basis. For say, I'm doing some transaction. I'll show you. So if I have a Bitcoins, right, and I want to book a flight tickets, right, there is a website called a Bit Sky. So I book my flight tickets with Bitcoins with this particular website, a Bit Sky. You know, you can definitely book your flight tickets with the Bitcoins, fly for Bitcoins. Then you can book the hotels and all. You can go to Bitsell, see bitsell.in, and you can buy the gift card. You can go to e-gifter and you can buy the gift card from the Bitcoin, I can say. You can go to Propy, and then you can buy the property from the Bitcoin. So these are the different, see here, they will have a Bitcoin as a mode of payment. You can buy any gift card, Amazon, Wayfair, Home Depot in US. So if you select the country India, you'll be able to buy the Indian gift card. So, telling definitely I and any one of us really do not need money, because you can buy property, you can pay bills. If you go to Amazon.in and if you go to Amazon Pay, you can definitely pay the bills from Amazon Pay. You see, you can pay the bills, you can do the mobile phone recharge and all of that by buying the gift card. So you can just buy the Amazon.in gift card, pay your electricity bill, pay the DTS, pay your insurance. So this how you can even book a flight, bus, anything and everything. So just buy the Amazon gift card from Bitcoin and then pay your bills. So this is wonderful utility. I meant to show you tomorrow, but here we are. I could not uh, resist myself. So these are the utilities. Now, whenever you do the transaction, make sure always track the blockchain and audit it on the Block Explorer to verify the transaction and metadata, and look for the potential double spending transaction. See for the priorities, that what fees the user has already paid to pay you the Bitcoins. For say I meant to pay you 5 Bitcoins, that have I paid the appropriate fees on the blockchain, or I just paid 1 Satoshi per byte to delay the process, to double spend. Because there is a attack called raised by value, which enables user to double spend. Like I will spend 1 Satoshi per byte as fee by sending Bitcoins to you, and by sending Bitcoins to anyone else, I will spend more, 15, 25 Satoshi. So that block will mine first. So that's how double spending works. And that's how, people are being victim of this thing, and they contact me in Bitwill and Skinox that, hey, you know what, I got double spended and all. So right now there are mitigations to that, but why to take risk, So that's why you have to check inputs and outputs and see whether the user is authenticated or not. The second step for this is wait for the blocks to be mined. Suppose we are making a transaction, you do not acknowledge or confirm the transaction until the block is mined. Wait for the block to be mined, wait for the confirmation, and then at least you get 3 confirmation, and then you leave the place, or then you acknowledge or give your system and service, so there are no chances of double spending. Third thing is, make sure you never ever share your private key with anyone. You can share your public key, but do not share your private key. Those who hold your private key will hold your funds. Okay. Never keep a copy of a private key unencrypted and online. Always keep it offline, encrypted. Do not use online wallets, generally a hot wallet, which can keep your private key online, because they are high security risk, because they're hosted with a third party server. You never know. And never ever trust anyone while conducting a trade or transaction on blockchain. Always verify, always generate the wallet means the private key and public key in isolated and air-gapped offline environment in your computer. Always install clean OS before and after you generate the wallet, and always back up your system, okay? And use open source system and OS to prevent any malicious attack and any other tampering of your OS or the whisperer, or I can say the man in the middle, you know. So this is everything, and please feel free to ask the questions. And please remember, do not trust, always verify. Thank you. Thanks for tolerating me from 1.5 hours. Please ask any question if you have.
Okay, thank you, sir. Dear participants, if you have any questions, you can ask to Jay, sir.
Yeah.
Yes, participants, any questions?
I think I have used a very layman language so people can understand. I don't want to be very technical and this graph and that's graph.
Yes,
So
yes,
to make sure that blockchain is accessible to everyone. And
yeah.
sorry if I at all sounded boring, but the topic is like that, Bitcoin transaction. But tomorrow we are going to host the blockchain wallet where I'll show you the hardware wallets. I'll show you all the crazy things. Even the DIYs will be there. So tomorrow it's going to be exciting. Yeah. Don't get bored.
Yeah, okay,
So any
sir.
questions? Anyone? All set?
Yes, any questions? Please do ask the questions. Obviously, sir has used a very simple language to explain the very difficult concept, and maybe, sir, that's why the people doesn't find any kind of question. Okay, that's a really great, sir.
Ah, thank God. Thanks for
Yeah,
tolerating me from this long. Yeah. I was keep on
yeah.
speaking.
I'm really thankful, Jay, sir, for giving such a nice session. For you
Thanks a lot.
explained very nicely the cryptographic transaction diagram and what is the role of the crypto miners, how they are getting rewarded, okay, and what is the role of the blockchain nodes, blockchain wallet,
Blisters.
and what is the nonces, how the consensus algorithm work, and obviously what is the Byzantine fault. That is a very important concept. You explained very nicely, sir. So once again, thanks a lot for giving a precious time to us.
So it's a pleasure. It's always a pleasure to unfurl demystify the blockchain.
Yes, sir. Yes, sir.
Thank you, sir, for your informative session.
Yep.
Thank you,
So
sir.
shall I take your leave now?
Yes, sir. Yes, sir.
Yes, sir.
Perfect. Thanks a lot, and may God bless you all.
Bye. Thank you, sir.
Okay, thank you. Thank you, sir. Okay, so dear participants, now we'll be having a lunch break from 1:45 to 2:15. So see you all at 2:15. Okay, and be there on time so that we'll be starting with the session number 6 by Dr. Mukesh Mohaniya. Okay, okay, fine.